examples of distance formula. Now in this question, what point on y-axis? So this point that we are looking for lies on y-axis. So we already know that the coordinates will be of the type 0 comma something, right? Because this point that we are looking for lies on y-axis, hence its x coordinate will be 0, right? So what we need to find is this coordinate. Now what point on y-axis is equidistant from the points 3 comma 1 and 1 comma 5? So let us say these are these 2 points 3 comma 1 and 1 comma 5, and we are looking for a point which has got x coordinate as 0 and y coordinate as, let us say, y. Now this point is equidistant from this point and this point, so these two distances are equal, right? Now we will apply the distance formula here to find this distance, and then we will apply the distance formula once again to find this distance, and we will put these equal to each other to find the value of y. Now let us find this distance first. So applying distance formula, difference of abscissa 3 minus 0 squared, that is 9, plus difference of ordinates 1 minus y squared, and then we will take the square root. And to find this side, difference of x coordinates, that is 0 minus 1 squared, that is 1, y minus 5 squared, and then square root. Now we can put this and this equal because these two sides are equal, right, because of the given information in the question. So we can also remove the square roots because we are putting them equal, and then squaring, we can remove the square root signs or the radical signs. So let me put 9 plus 1 minus y squared equal to 1 plus y minus 5 squared. Okay, so let us simplify this further. 9 plus 1 plus y squared minus 2y will be equal to 1 plus y squared plus 25 minus 10y, right? Y square, as you can see, can be cancelled, and here I've got this 9 plus 1 equal to 10 minus 2y. On the right hand side I've got 25 plus 1 26 minus 10y, right? If I bring this 10y on the left hand side, it will be 10y minus 2y, that is 8y, and if I bring this 10 on the right hand side, 26 minus 10 will give me 16, hence 8y equal to 16, which will give me y equals 2, right? So the point that we are looking for has got coordinates 0 comma 2, right? Because this is a point which lies on y-axis, hence it has got x coordinate as 0. Y coordinate we have found by applying the distance formula. Okay, let's look at the next question here that we have. If Q and R are given and P lies on the right bisector of QR. So let me draw QR first. Let us say this is Q 2 comma 1 and this is R minus 3 comma 2, and this point P lies on the right bisector of QR, which means this is a perpendicular bisector. This is a line which bisects QR, that is this segment will be equal to this segment and is perpendicular to QR, right? And this point P lies somewhere on this right bisector or perpendicular bisector. Now what is the property of points lying on a perpendicular bisector of a line segment? Let us say these points lying on the perpendicular bisector of this line segment, what will happen is these are equidistant. Let us say this point is equidistant from these extremes of the line segment. Similarly, this point is also equidistant from these extreme points of the line segment, that is this is equal to this, right, and this is equal to this, and this will be true for any point lying on the perpendicular bisector. I hope all of you know this from your knowledge of class 9th. Otherwise, let me tell you once again. If let us say I draw this perpendicular bisector, then this segment is equal to this segment. Now if I take any general point on this perpendicular bisector, what will happen is, if I join this with the extremes here and this extreme here and look at these two triangles, this side is equal to this side and this side is common to both these triangles, and this angle is 90 degrees, so this angle is also 90 degrees. So by side angle side congruence criterion, I can say that these two triangles are congruent, and this will be true for any point lying on the perpendicular bisector. You will have two congruent triangles. Hence I can say the corresponding parts of the congruent triangles are equal. Hence this length will be equal to this length. Similarly this will be equal to this, and similarly I can say this length here will be equal to this length. I hope you have understood that this point P is equidistant from Q and R. So I can say that PQ is equal to PR. Okay, so what I need to do here is I just need to apply distance formula on PQ to find PQ and PR and then put them equal to each other. So let me apply the distance formula on PQ first. So I can say PQ is equal to square root of x minus 2 squared plus y minus 1 squared. This is PQ, and I'll put it equal to PR, which is x minus 3, that is x plus 3 squared, y minus 2 squared plus y minus 2 squared. Okay, let me now simplify it. I hope this line is not disturbing you. Right, so let me open these brackets. I can simply square both sides and remove these radical signs, and then I am simplifying it, opening the brackets. So this will be x square plus 4 minus 4x, right? And this will be y squared plus 1 minus 2y. I'll put it equal to x squared plus 9 plus 6x plus y squared plus 4 minus 4y, right? So x square and y square will be cancelled on both sides, right? And minus 4x and 6x will become 10x on the right hand side if I bring it on the right hand side, minus 2y if I bring on the right hand side, and this is minus 4y. So minus 4y plus 2y will become minus 2y. Alright, and this is 4 plus 1, 5. So if I bring this 5 on the right hand side, I have already got 9 plus 4, 13 here. So 13 minus 5 will give me 8 here, and it is equal to 0. Okay, so now I've got this linear equation. You can see that I can take 2 common from all these three parts. So if I take 2 common, it will be equal to 5x minus y plus 4, right? So 2 into this expression is equal to 0, right? So for this right hand side to be equal to 0, this expression will have to be equal to 0, and this is what we need to show. So this implies 5x minus y plus 4 is equal to 0. This is what we need to show here. Alright, so this is a simple application of distance formula and simple class 9th knowledge that every point on perpendicular bisector of a line segment will be equidistant from the two extreme points of that line segment. Okay, let us take this question here. The vertices of a triangle are these. Is the triangle equilateral, isosceles, or scalene? Right, we just need, let us give them names A, B and C. So I just need to find the distances AB, BC and CA, right, using the distance formula. And then if these three distances are equal to each other, then I can say this triangle is equilateral. If any two of them are equal, I can say this triangle is isosceles. If none of them is equal to each other, then this triangle will be scalene. So this is simple distance formula. Let me do it very quickly. So to find AB, what I can do is square root difference of abscissa, minus 2 that will become minus 4 squared 16 plus 0 minus 3 minus 3 squared 9. So 16 plus 9 25. It will give me 5 units. So AB is 5 units. BC 2 minus 1 squared that is 1. 3 minus minus 3 will become 6 and 6 squared will become 36. So I'll add it here and then I'll take square root. So it will give me root 37 units, right? And then I need to find AC. To find AC, minus 2 minus 1 that is minus 3 squared will give me 9. 0 minus minus 3 that is 3 squared will again give me 9. So 9 plus 9 square root will give me root 18 units. As we can see, AB is not equal to BC, is not equal to CA, which means the triangle in question is scalene triangle. Alright, so this was another simple application of distance formula. Let us see if we have got some more questions. Yes. Name the quadrilateral formed, if any, by the following points and give reasons for your answer. So let us again name these points A, B, C and D. And now I'll try to find AB, BC, CD, AD, which will be the sides of the quadrilateral if such a quadrilateral is formed by these points. So let us first of all find these distances using the distance formula. So AB will be difference of abscissa, that is minus 1 which is minus 2 squared will give me 4. Minus 2 minus 0 minus 2 squared will give me 4. So 4 plus 4 8. Square root of 8 can be written as 2 root 2 also. Okay, now to find BC, again 1 minus minus 1 that is 2 and 2 squared is 4. 0 minus 2 minus 2 squared 4. So root 8, again this is 2 root 2. CD minus 1 minus of minus 3 which will become plus 2. 2 squared is 4. 2 minus 0 2 squared 4. So again it will give me the same length, that is 2 root 2. Okay, AD minus 1 minus of minus 3 will give me plus 2. What I'm saying here is minus 1 minus of minus 3 and then I'll square it, right? So it will be minus 1 plus 3 which is 2 squared will give me 4. And then I'll add minus 2 minus 0. So again it is minus 2 squared, right? This is what I am saying, which is nothing but this is 2 squared is 4 and then minus 2 squared is again 4. 4 plus 4 is 8 which is 2 root 2. Now all these four sides AB, BC, CD and DA are equal in length. So what can I say about this quadrilateral? I can say that this will be a rhombus, but will it be premature to say something about this quadrilateral? Yes, because when four sides are equal, what you are supposed to do is you need to check the diagonal length. Because if the diagonals are also equal in this case, then this quadrilateral will become a square, right? So if I draw this quadrilateral A, B, C, D, I have already shown that this is equal to this, is equal to this, is equal to this, right? So it will be a little early to say about this quadrilateral, right? I can simply, by looking at these four sides being equal, some students can directly say that this is a rhombus, right? But now that I've shown that four sides are equal, I just need to check whether these diagonals are equal or not, AC and BD. So let's first of all calculate the lengths AC and BD. So what is the length AC? Minus 1 minus of minus 1 will become 0, right? So 0 squared is 0 plus minus 2 minus of 2 which will become minus 4 squared, that is 16. So square root of 16 is 4. BD 1 minus minus 3 that is 4. 4 squared plus 0 minus 0, that is 0. So 0 squared is again 0. So BD is also 4. As you can see that diagonals are also equal. Diagonals are equal. Sides are, I've already shown that these are equal. So this quadrilateral in question is a square, right? So this was another question on distance formula.